Hello folks, welcome once again. In this video, I'm going to let you know how to progressively load the batch of image data for training the image captioning model. This is sometimes requires when you don't have enough RAM to process the images. As you know, deep learning models possess several neuron layers to process their data, as well as you run multiple epochs to train the model. Hence, there is a requirement of training the model progressively when we don't have enough memory. We are also going to see how to train and fit the image caption model. So please watch this video till the end to acquire the required knowledge on it. So what is progressive loading? Well, there are times when we don't have enough memory on the system on which we are training our image based models. The model we developed in previous video can't be just trained on the system with just 8 to 12 GB of RAM. We actually need a RAM above 32 GB to train the model. You can either use the cloud-based GPU machines having enough RAM to train these models, or train them progressively. Keras supports progressive loading data sets by making use of a function called fit generator. We basically develop a standalone function or generator here, the name of which can be then passed to the fit generator function when fitting the model. This function or generator must create and yield one batch of data set. As we know that a particular deep learning model is fit on multiple epochs, where one epoch depicts one pass to the entire training data set of images. Now, one epoch is comprised of multiple batches of data, and model weights get updated at the end of each batch. If you want to know more about how deep learning models get trained, then watch the video given in the I button above. Hence, we are utilizing this custom data generator function called data generator, right? So let me open the Jupyter notebook real quick. So this is the custom function we are building. So this function called data generator, which actually, when given a dictionary of image identifiers, there's corresponding description, a tokenizer, maximum word sequence length, and vocabulary size, will load one image worth of data per batch. Here inside this function, we are using a for loop. Inside this function, we are actually using the while loop first to go over each image and incorporating for loop right underneath that to extract image features from the image given in the dictionary. Okay. Here we are utilizing this create a sequences function to create batch worth of data for a single image rather than an entire data set. In the next cell, I'm just checking image and description training data size as well as vocabulary size and maximum description length here. So I'm just providing the flickr 8k train image.txt file as an input, and then utilizing several functions which we have developed in previous videos to get this information, which is shown here. So in the next cell, I am training our our image caption model by saving it after each epoch. Okay, so at the end of all the 20 epochs, you will have 20 separate .h5 extension files, starting with model underscore, which is shown here, right? Okay, followed by a numeric value, okay, for a given iteration of the epoch, followed by .h5. Okay, here what we are doing is we are first using define model function to instantiate. So this define model function, okay, I'm utilizing this function to instantiate our model, the image caption model, and number of epochs defined here are 20. Okay, so the steps basically here is a parameter which is equals to size of train descriptions, which is 6,000 as you can see here. Okay, next I'm incorporating for loop here, as you can see, uh, to create the data generator using data underscore generator function, as you can see here, right? And then I'm using Keras fit generator function to train the model with this data generator. Okay, lastly I'm saving our model after each iteration. So when I ran this cell, all the 20 epochs were executed, as you can see here, thereby saving 20 files for each iteration. Okay, you can see those files here. Okay, model underscore 0.h5. So I already told you the name of the file was defined here, model underscore the iteration number and .h5. So after each epoch, one file was saved with this particular naming convention. Okay, so overall there were 20 files generated starting with 0 till 19. Okay, as you can see here. So we can now evaluate each saved model and pick the one or so these are separate models here, right? So 20 different models. So we can now evaluate these saved models and pick the one which has lowest loss or error on a holdout data set. I will be covering the model evaluation topic in the next video, so stay tuned for it. Now, by utilizing this method, you can save a lot of memory of the system. So folks, this is it for this video. To conclude, we learned about how to progressively train our image caption model when we don't have enough memory or RAM. So let me ask you a question from today's video. At the end of all the epoch, which saved model file can be used for predicting captions? Please post your comments in the comment section given below so that I can get a chance to incorporate your feedback. You can also ask your technical questions in the comment section given below. I will be glad to answer your questions. If you are watching this video and you are not already a subscriber to our channel, consider clicking that little subscribe button. In case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me, guys. I will be covering next topic in the upcoming video, so keep on watching. Thank you.